Students, good morning. Today I am going to discuss about the Clapeyron equation. Clapeyron equation. This equation is very much essential in estimation of changes in enthalpy during phase change. Say for example, you are having a system. System is nothing but liquid. If liquid is converted into vapor, if the system is converted into vapor, this process is called as vaporization. Vaporization. Clear? Similarly, the system of liquid is converted into solid. The process is called as freezing. Freezing or fusion. Freezing or fusion. The changes in enthalpy in vaporization is called the enthalpy of vaporization. Enthalpy of vaporization. Similarly, the changes in enthalpy during fusion is called the enthalpy of fusion. Is called as enthalpy of fusion. So Clapeyron equation is very much essential in estimation of changes in enthalpy during vaporization. Enthalpy of vaporization, changes in enthalpy during freezing, call it as enthalpy of fusion. So estimation of enthalpy change during phase transmission, knowledge on Clapeyron equation is very much essential. Now let us start to derive the Clapeyron equation. For this, let us consider a system. System contains both phase. One is liquid, another one is vapor. This is liquid. This is vapor. Both phases are in equilibrium condition. Both phases are in equilibrium condition. Equilibrium condition at constant temperature, and pressure. Both phases are in equilibrium condition at constant temperature and pressure. The free energies of the phases. For liquid, you can write del G1. For vapor, you can write del G2. Or you can write like this del G vapor, similarly del G liquid, whatever it may be. Now I am going to calculate the changes in free energy. Since both phases are in equilibrium condition, the free energy change becomes zero. Total change del G is equal to 0. Or I can write like this del G2 minus del G1 is equal to 0. The same equation can be written like this del G2 is equal to del G1. Now I am going to find the free energy change from fundamental property relations. What is the relationship for free energy change? dg is equal to vdp minus s into dt. This is the third fundamental property relation. The canonical variables for Gibbs free energy is pressure vdp minus s into dt. Pressure and temperature are the canonical variables of the Gibbs free energy. Clear? Right. Now I am going to derive the Clapeyron equation for this estimation of free energy change during the phase change. Okay. For this, the Clapeyron equation is derived by correlating the thermodynamic properties pressure, volume, temperature. This Clapeyron equation is derived from the thermodynamic properties pressure, volume, temperature. In this case, pressure is always saturation pressure. Pressure is always saturation pressure. Saturation pressure. This pressure depends only on temperature. It depends on temperature. Depends only on temperature. Only on temperature. It does not depends on volume. It does not depends on volume. Clear? By changing any of the properties, the system state of the system will change. Clear? Now let us start to derive the equation from third fundamental property relations, changes in Gibbs free energy. Now, now I am going to write this equation in terms of this dg v dp minus s into dt for del g2 this equation becomes v2 dp minus s2 dt. This is equal to del g1. The equation becomes v1 dp minus s1 dt. For sign change, v2 minus v1. Listen, v2 dp minus v1 dp is equal to, this is on this side, s2 into dt minus s1 into dt. Hence, this equation becomes v2 minus v1 divided by dp is equal to s2 minus s1 into dt. Clear? So dp by dt is equal to s2 minus s1 divided by s2 minus s1 divided by v2 minus v1. This is the final equation. Now I am going to alter this equation like this. Changes in pressure with respect to temperature is equal to del S. S2 minus S1. S2 minus S1 is equal to del S divided by V2 minus V1 divided by V2 minus V1. V2 minus V1. Second law of thermodynamics says that second law of thermodynamics says that del S is equal to Q by T for a reversible process. Hence, I am going to write like this: dp divided by dt is equal to 1 by T into Q divided by V2 minus V1. The changes in enthalpy in a reversible process, the changes in enthalpy in a reversible process is del H is equal to Q. Del H is equal to Q. Hence, I am going to write like this: dp by dt is equal to 1 by T into del H divided by V2 minus V1. This is Clapeyron equation used to estimate the changes in enthalpy during phase transmission. That means enthalpy of vaporization and the enthalpy of fusion. Thank you.